Academy for you. In today's lecture, we will start digital communication. Now, in digital communication, we have to transmit a signal in digital manner. Now, the very first question that arises in our mind is why we need to transmit a signal in digital form. We are having a message signal that is analog in nature, and we are having two options in order to transmit a signal. First option that we have shown here, that we are having a message signal that is analog or continuous in nature. Continuous means at every instant of time we are having certain value. So when you join it, you will combine it, you are having a continuous value, that is an analog signal. So you can transmit this analog signal directly through a channel. This is the first option, that we can transmit a message signal. Now the second option we are having is we are having an analog signal. We are transmitting it through a channel as a digital signal. Now how can we convert an analog signal into a digital converter? Is by using ADC. ADC is analog to digital converter. Now after passing through channel, we are receiving whatever we are sending. So we have transmitted this value, so definitely we are receiving this only in digital manner. Now digital definitely means binary only, that is 1 and 0. So our signal that was continuous in nature now becomes a series of 1 and 0. So this is a digital signal. Now because our message signal was analog in nature, so in order to retrieve that signal, we have to pass it through digital to analog converter so that it can be back into its original form and we can reconstruct that message signal properly. So we are passing it through a DAC, that is digital to analog converter, and finally we can retrieve, we can reconstruct the message signal. So this is a manner of transmitting a message signal. Now there are two options, option 1 and option 2. We should prefer option 2 for transmitting a message signal. Why we should prefer digital communication as compared to analog communication? Because digital signal, or we can say that digital communication is much more noise free. This is having much more noise free environment as compared to analog communication. So we have to convert a message signal that is analog in nature into digital form. Now what are the steps that we need to have? These are the steps that we need to have, but before that we have to know about a theorem, that is sampling theorem. Sampling theorem is a theorem through which we can reconstruct a message signal properly. What are the criteria in this? This is given by Nyquist. So what are the Nyquist criteria? How the theorem will work? What are these terms meant for? We will have a look into that in detail. So the steps that we are having is continuous signal. First we need to sampling it, then we need to quantize it, we need to have quantization, then we need to encode it through encoding, and finally we will have a digital signal. As the name of this theorem that is given by scientist Nyquist is sampling theorem, so first we need to understand the word of the very first term, that is sampling. So how we can sample a signal? The first method that we can sample a signal is by using an electrical switch. Here we are having a continuous signal, that is an analog signal, and we are having the value of message signal at every instant of time. So combinedly we are having a signal like this. We are having an electrical switch, and this switch is having the time interval, that is the sampling interval, that is of 1 millisecond, TS. TS equals to 1 millisecond. It means after every TS, that is after every 1 millisecond, the switch will on and we will get the respective value. For this you can consider it as like you are having a camera and every after 20 seconds, and after 20 seconds, that is a sampling interval, you are clicking the pictures. So whatever the thing is going around you, at every 20 seconds you capture that images. So just like you can say that this is a message signal that is going, and at every 20 seconds you are clicking the picture. Here I am taking as t equals to 1 millisecond. So at t equals to 1 millisecond, I am not considering you to take an example that is practical, just like I am saying clicking the picture, because you can't click the picture manually at t equals to 1 millisecond. So here we are saying that at TS we are clicking like a picture. So this was the value at TS and we have captured it. Now at 2TS, after every TS, I mean TS, then 2TS, 3TS and so on. So at 2TS, whatever was the strength of the message signal, we have captured that value. Whatever the information was there at 3TS, we have captured that information. So this is a sampled signal or a discrete signal. This is not a digital signal because digital signal comprises binary form. But this is not a binary form, this is a discrete signal. Now, TS is our sampling interval and Fs, that is the inverse of TS, that is the sampling rate. Here we are having a message signal that is unlimited bandwidth message signal. Now if we are having an unlimited band or band unlimited signal, that is a message signal is band unlimited in nature, then we know from signals and systems that its Fourier transform will be a band limited signal with the frequency lies from -fm to fm, where fm is the frequency of the message signal. Now our sampling theorem states that we can reconstruct this message signal properly if we are using the formula, the concept that Fs is greater than equals to 2fm. If we are using this concept of Fs is greater than equals to 2fm, then very easily we can reconstruct our message signal. Here we are having Fs is greater than 2fm as well as Fs equals to 2fm. If we are having Fs is greater than 2fm, then it is valid for ideal and practical applications. Whereas if we are having the value Fs equals to 2fm, that is valid only and only for ideal cases. So if we are having the concept that our sampling rate, the sampling rate is greater than equals to twice the message signal frequency, then easily we can reconstruct our message signal without any loss of information. Now just I have told you that Fs should be greater than equals to 2fm. That is meant by our sampling theorem, and based on that we are having the classification of sampling. The very first is that Fs is greater than 2fm. If Fs is greater than 2fm, then you know that 1 upon Ts is your Fs. So you can write it like this, or Ts is less than 1 upon 2fm. So this is our oversampling. Now if Fs equals to 2fm or Ts equals to 1 upon 2fm, that is our critical sampling. And if Fs is less than 2fm or Ts equals to greater than 1 upon 2fm, then it is our undersampling. So we are having three basically classifications of sampling. Based on that, oversampling and critical sampling can be done in order to construct a message signal perfectly. Now let's have a focus on proof of sampling.